Hey guys, exponential review sheet. Eventually we'll do a little practice quiz on this, so let's take a look. So rewrite the following using only positive exponents. Well, first off, when we divide, we subtract the exponents. So 2 minus negative 4, 6, and negative 3 minus 2, negative 5. So we get a to the sixth, b to the negative fifth, but we want only positive exponents. So to make negative exponents positive, we flip their location. So the final answer, a to the sixth over b to the positive fifth. The value of 8 over 27 to the negative 2/3. Now the good thing is you can do it right in the calculator, and that's how I would expect you to do it, but I am going to show you the way to actually do it. Let's see. So 8 over 27, and that raised to the negative 2/3. And you get 9 over 4. Now, how do we get 9 over 4? Well, let's take a look. The way to write this, 1 over 8 over 27 to the positive 2/3 power. And remember, exponents, it's power over root if you have a fractional exponent. So that means 1 over the cubed root, because the root is 3, of 8 over 27 squared, which is, what is the cubed root of 8 over 27? Well, you can do the cubed root of 8 over the cubed root of 27, right? What number times itself 3 times is 8? You can do it in the calculator. It's 2. What number times itself 3 times is 27? You can do it in the calculator. It's 3. So you get, and I'm just going to go over here, 1 over 2/3 squared. Don't forget the squared on the outside here, which is 1 over 4/9, which when you keep switch flip is 9/4. Just do it in the calculator though. Explain how 3 to the 1/5 squared can be written as an equivalent radical expression, the fifth root of 9. Well, power to a power, power to power, multiply. So we get, let's see, 3 to, what is 1/5 times 2 over 1? It's 2/5. So you get 3 to the 2/5, and then again, power over root. So this is the fifth root of 3 squared. Well, what's 3 squared? 9. So it's the fifth root of 9. All right, here we go. Same base, subtract the exponents. What's 2/3 minus negative 3/3? Or plus positive 3/3? That's 5/3. So that's 5 to the 5/3 power. If you want to rewrite this, power over root, it's the cube root of 5 to the 5th power. Which of the following is equivalent to 3a to the 2/3? Well, 3a to the 2/3, power over root. So it's the cubed root of 3a power squared. Right, the root is the number out here, and the power is what you're raising it to. Okay. Oh, actually, there's a mistake there. That's not the answer, and that's because 3a is being squared. This is just saying a is squared. So the answer is actually, what is 3a squared? Well, it's 9a squared, so it's this choice. Sorry about that. 6. When b is greater than 0 and d is a positive integer, the expression 3b to the 2 over d is equivalent to, let's see, so that means power over root. Oh, there you go. The root is d, the power is 2. All right, so So this is just a plug in. If f of x equals this whole big thing, then what is f of 4? Just plug it in. So you get 4 to the negative fourth plus 4 to the 0 plus 4 to the fourth. Right? And we could just do this right in the calculator. 4 raised to the negative fourth plus 4 to the 0, which is 1, plus 4 to the fourth. And there you go. You keep it as a fraction, it's a little cleaner. 65,793 over 256, which is about 257, a little more. All right, now let's get into some exponential stuff here. The distance needed to stop a car after applying brakes varies directly with the square of the car's speed. The table below shows stopping distance for various speeds. So if you're going 10 miles per hour, it only takes you about 6.25 feet to stop, but if you're going 70, it takes you about 306. It's not linear. It's not going up by the same each time. So it says determine the average rate of change between a car traveling 50 miles per hour and 70 miles per hour. So basically, remember, we're finding the slope between these 2 points. And your speed is your x and your distance is your y. So you get this is x1, this is x2, this is y1, this is y2, and you have to find the slope. So it's y2 minus y1 over x2 minus x1, which is, let's see, 306.25 minus 156.25 over 70 minus 50. And you do this in the calculator. What is the average rate of change? Let's see. 306.25 minus 156.25. Put that in parentheses, divide that by 70 minus 50, which is 20. And you get 15 over 2, or 7.5 miles per. Let's just leave it at 7.5. So on average, it takes you 7.5 feet per 1 mile per hour. Right? So for every mile per hour you go up between 50 and 70, it takes you about 7.5 more feet to stop the car. All right, which of the following represents exponential decay, right? Exponential decay, we know the graph over time is going down. It looks like this, right? Now, usually, if the base is between 0 and 1, right, is decay. So you might think it's choice 3, but you should always graph to make sure it is or is not. Let's see. 1/2 raised to the negative x, and that is not decay. Right? So what is the answer? I think it ends up being 5 raised to the negative x. Yep, that's decay. So that's choice 4. All right, number 10. When simplified, the expression is equivalent to. So first off, you can simplify what's inside here first because they have the same base. So division, you subtract the exponent. So -5 minus -9. Oh, keep change. That's 4. So you get w to the 4th to the 1/2. Right? What is the 1/2? Well, power root. So it's the square root of w to the 4th to the 1st. We don't need to put that. So what's the square root of w to the 4th? What times itself twice is w to the 4th? W squared. The expression here is equivalent to, well, you could split this up into 3 problems. You can do the 4th root of 81 times the 4th root of x squared times the 4th root of y to the 5th. All right, 4th root of 81, what times itself 4 times is 81? It's 3, so that means it can't be this, it can't be this. What's the 4th root of x squared? We'll rewrite this as power over root. And same here, power over root. And which choice is this? It ends up being 1. Which statement is true about this following exponential function? Well, just graph it and see which one is true. 3 raised to the x plus 2 plus 1 Well, first off, I see right away the y-intercept is not 0, 1. The range is greater than 1. Yeah, I think that's it. Right? It's a horizontal asymptote at 1, so it can't be 1. Remember, if we zoom in, it's not going to actually, so you could see, there's 1. It's not touching 1 as a horizontal asymptote, so that's your answer. Domain is x is greater than 1. No, that's not true. It goes left and right forever. And the asymptote is y equals 0. No, this would be y equals 0, right? But we have y equals 1 as the asymptotes. There you go. 2 more. The amount in milligrams of a 10 milligram dose of a drug after t hours is given by the formula a of x equals 100 times 0.8 to the x. Right? That means it starts at 100 and it's 0.8. You multiply by 0.8 each hour. So how many more milligrams are in the body after 1 hour than after 2 hours? So to do this, we graph it, 100, 0.8 to the x, and we do our table of values. Let's go from 0 hours to, we only need to go up to 2. So after 1 hour, there's 80. After 2 hours, there's 64. So how many more milligrams after 1 hour, which was 80, then after 2 hours, which is 64? Well, just subtract them and you get 16. Which function has a greater average rate of change over the interval from -1 to 5? Well, that's again, you have to find the slope. So let's find the slope of the chart first. That's easy. So you get x1, y1, x2, y2. So you get 223 minus 1 over 5 minus -1, which is 222 over 6. What's that? Let's see. 222 divided by 6 is 37 over 1. Now what about this function? We got to graph it. 3x cubed minus 5x squared plus 6. And we want to know from, table of values, from -1 to 5. So you get the points -1, 2, -2. You get 5, 256, and now we have to find the slope. 256 minus -2 over 5 minus -1. That's 258 over 6, which is 43 over 1. So which one has a greater average rate of change? G of x. Okay.